Welcome back. I am your expert technical instructor. In this session, we tackle a critical component of designing and implementing a package management strategy, establishing a robust dependency versioning strategy, utilizing both semantic versioning and date-based versioning. As software engineering transitions toward highly distributed microservices architectures, the complexity of managing shared libraries and code assets multiplies dramatically. Without a rigorous, mathematically precise dependency versioning strategy, continuous delivery descends into sheer chaos. If a central authentication library is updated without proper version indicators, every single consuming application could instantaneously break during deployment, crippling the organization. Designing a strict versioning strategy establishes an immutable contract between the developers creating the package and the engineering teams consuming it. This contract provides absolute predictability. Consumers must know definitively whether a package update introduces harmless bug fixes or entirely breaks backward compatibility by altering public API signatures. By implementing a standardized versioning nomenclature and strictly enforcing it via Azure Pipelines transformation, teams ensure that artifacts remain immutable, rollbacks are always exact, and the software supply chain maintains absolute integrity across the entire enterprise ecosystem. This XML syntax demonstrates strict dependency versioning in action. The consumer explicitly demands version 3.2.1, rejecting any unverified future updates that could introduce breaking changes. The versioning contract. The author publishes an update. The version engine assigns a strict number, creating an immutable artifact that guarantees a predictable restore for consuming applications. The industry standard for managing code assets and library packages is semantic versioning, universally abbreviated as SemVer. SemVer relies on a strictly defined three-part numbering system, major.minor.patch. Each number communicates a highly specific architectural intent to the consuming developer. The patch number is incremented exclusively for backwards compatible bug fixes that do not alter the API. The minor number is incremented when you introduce brand new functionality, but the package remains entirely backwards compatible with existing consumers. The major number is incredibly significant. It is incremented only when you introduce breaking changes that destroy backward compatibility, explicitly warning consumers that they must refactor their integration code before upgrading. By strictly adhering to SemVer, your package management strategy inherently communicates risk. Automated systems and developers alike can confidently accept patch and minor updates automatically, while intelligently halting and isolating major version upgrades for rigorous manual regression testing and architectural review. This sequence elegantly illustrates the mathematical progression of SemVer. Notice how incrementing the major version resets the minor and patch versions back to zero. The SemVer decision matrix. Bug fixes trigger a patch bump. New non-breaking features trigger a minor bump, and breaking API changes absolutely require a major version bump. While semantic versioning is the undisputed champion for shared code libraries and NuGet packages, it is not always the optimal strategy for massive, standalone end-user applications or continuous deployment web services. For these scenarios, designing a strategy around calendar versioning or CalVer is highly recommended. CalVer utilizes date-based formatting, typically following a year-month-day structure, occasionally appended with a daily build increment. Because an inherently monolithic web application does not have downstream developers worrying about its internal API backward compatibility, communicating breaking changes via a major version number is largely irrelevant. Instead, CalVer provides instantaneous, human-readable operational context. If a user encounters a bug, a support engineer can look at the CalVer number, the 24th of May 2026, and know instantly exactly when that code was compiled and deployed. This strategy is immensely powerful for organizations embracing high-frequency deployment cadences, simplifying the correlation between live software versions, server-side log analytics, and specific sprint tracking milestones within Azure boards. This string represents a standard CalVer format indicating the year, month, and day of compilation, followed by a .3 indicating it is the third automated pipeline build executed on that specific date. The CalVer generation process, the pipeline triggers, extracts the current system date, fetches the daily build revision count, and concatenates them to generate the final calendar version. A critical component of a dependency versioning strategy is managing work-in-progress code. Before an artifact is finalized, it must undergo extensive integration testing. To prevent these experimental builds from being confused with stable releases, teams must implement pre-release versioning syntax. In SemVer, this is achieved by appending a hyphen and an alphanumeric identifier to the version number, such as 1.2.0 beta or 2.0.0 RC.1. This nomenclature is not merely cosmetic. It fundamentally alters the behavior of package management tools like NPM or NuGet. By default, these tools will absolutely refuse to download a package marked as a pre-release, unless the developer explicitly adds an override flag to their command line request. This built-in safeguard guarantees that experimental, unstable code is never accidentally pulled into a production compilation process. Designing your CI/CD pipelines to automatically append these pre-release tags to feature branches ensures that developers can safely publish and share iterative dependencies via Azure artifacts without contaminating the stable, production-ready enterprise supply chain. This specific command demonstrates a developer intentionally overriding standard safety protocols to explicitly download an unstable alpha pre-release version for local integration testing. The pre-release branching logic. Feature branch compilations automatically append a beta tag for safe testing, while main branch merges strip the tag to yield a stable production version. When consuming these version packages, enterprise architects must mandate strict consumption rules, specifically the debate between dependency pinning and floating versions. Floating versions utilize wildcard characters like an asterisk instructing the build system to automatically download the absolute latest patch or minor version available at the exact moment of compilation. While this ensures applications instantly receive security patches, it destroys build predictability. A pipeline executed on Tuesday might produce an entirely different binary than one executed on Monday, strictly because an upstream package was updated. This violates the core DevOps principle of repeatability. Therefore, an enterprise strategy must strongly recommend dependency pinning, explicitly hard-coding the exact version number required, such as 2.4.1. To manage the administrative burden of pinned updates, organizations rely on lock files generated by package managers. These lock files mathematically verify and freeze the exact cryptographic state of the entire dependency tree, ensuring that continuous delivery environments construct identical artifacts with absolute, immutable consistency every single time. This JSON package manifest compares a highly safe, strictly pinned dependency version against a risky floating dependency using a caret, which automatically accepts unverified minor updates. Comparing consumption strategies. Floating requests fetch unpredictable latest versions leading to unstable builds, whereas pinned requests demand exact hash matches for immutable, repeatable compilations. Relying on developers to manually type and update version numbers in project files is an archaic, error-prone practice that cannot scale. A modern dependency versioning strategy automates version bumping directly within the CI/CD pipeline using Git history. By enforcing conventional commits, where developers prefix commit messages with labels like fix or feat, specialized pipeline scripts can autonomously analyze the Git log since the previous release. If the script detects a fix commit, it automatically bumps the SemVer patch number. If it detects a feat commit, it mathematically increments the minor number. The Azure pipeline then dynamically injects this calculated version string directly into the compiled artifact, publishes the package to Azure Artifacts, and automatically creates a corresponding Git tag on the repository. Marking releases with Git tags creates a permanent, searchable historical anchor, linking the exact source code state to the mathematically generated SemVer or CalVer package artifact. This pipeline task utilizes the standard version utility to aggressively parse Git commit history and autonomously calculate the exact next semantic version number required for the artifact. The automated versioning flow. Conventional commits are analyzed by the pipeline, which calculates the next SemVer, injects it into the package, and immediately generates an immutable Git tag. To summarize, designing and implementing a comprehensive dependency versioning strategy is the cornerstone of safe, scalable package management. By rigidly defining when to employ the API-focused nuances of semantic versioning for shared libraries versus the operational clarity of date-based CalVer for monolithic deployments, you establish profound architectural consistency. Furthermore, by automating these calculations within Azure pipelines and mandating strict dependency pinning via lock files, you eradicate unpredictable builds and accelerate continuous delivery. Please remember to thoroughly like this video, subscribe to our technical channel, and visit quicktechie.com for premium Azure DevOps certification preparation. At quicktechie.com, you will gain immediate access to comprehensive Q&A banks, high-fidelity ebooks, immersive audiobooks, advanced training simulators, and elite interview guides to master your DevOps transformation journey. Thank you for participating, and I look forward to exploring pipeline artifact versioning in our next intensive session. This advanced Git CLI command queries the repository specifically for version 2 tags and sorts them dynamically by version precedence, allowing automated pipelines to quickly identify the latest release. The path to excellence. An automated version engine produces immutable packages, consumed via strictly pinned files, resulting in flawless enterprise software delivery excellence.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. These are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechit.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.